Example 6 gives us a problem that's nearly identical to what we looked at in example 1. We simply have the inequality symbol pointed in the opposite direction. If we look back, or look again, at a number line to try to understand what this problem is asking us, what it's saying is we want all values of x that are more than 6 units away from 0. So in this case, we don't want the values that are contained between 0 and 6. Those values are less than 6 units away. So we want to start at 6 and consider all values that are more than 6 units away. So this would be all values greater than 6 with that open circle at 0, or I'm sorry, that open circle at 6, indicating that 6 is not included. And then if we consider the opposite direction, we would want to start at -6 and consider all values that are less than -6. So what this number line represents with these shaded areas would be all values that are more than 6 units away from 0 in both the left and right hand directions, or both the positive and negative directions. We could set this up as a pair of inequality statements by saying that x is greater than 6 and x is less than -6, which leads us into this idea of what we titled here as disjoint solutions. So in our previous cases, the two inequality statements created a bounded region. Those solutions sort of met up with each other, overlapped with each other. In this case, what we have are solutions where our two shaded regions are headed in opposite directions of each other. So anytime we have our absolute value statement greater than some value, we're going to see these disjoint solutions, our solution sets headed in opposite directions. And we'll add a little bit of additional notation to our interval notation. In order to represent the arrow headed to the left, we'll write the statement -infinity to -6 with a rounded parenthesis to indicate that -6 isn't included. And then we'll use this U symbol, which means union, or also means or. And then we'll write another interval, which will be from 6 to +infinity, with again a rounded parenthesis to indicate that 6 is not part of the solution. So this union symbol is telling us that our solutions to this inequality would be found in this interval or in this interval, meaning we would have all values less than -6 and all values greater than 6 as solutions to that original statement. So when we solve an absolute value statement greater than some value, we'll follow this pattern, where we take what was inside those absolute value bars and compare it to that original number, and then we'll take the what was inside those absolute value bars and set it to be less than the opposite of whatever that value was. And then in each case, we'll end up again with those disjoint solutions. In this case, we start off with 4x is greater than 8. This will give us two different statements to consider. So we had 4x inside those absolute value bars, and we'll set that to be greater than 8. And then we'll set up a second inequality statement where we set it to be less than -8. Solving both of those statements, we would get, in the first case, x is greater than 2, and in the second case, x is less than -2. Which would again give us this disjoint solution where we would have -2 and +2, but then our shaded regions would head in the opposite direction. Since we still have strict inequality, we would use an open circle and highlight or shade all values greater than 2. And then we would have an open circle at -2 and highlight or shade all values less than -2, representing those two disjoint inequality statements, which then we could turn into interval notation as -infinity to -2, union 2 to +infinity. In example 8, we'll start things off the same way. We'll consider x minus 5 to be greater than or equal to 1, and x minus 5 to be less than or equal to negative 1, and solve both inequality statements. So we'll get x is greater than or equal to 6, and x is less than or equal to 4. In this case, we'll use filled in circles because 6 and 4 are both included as part of that solution set. And we'll shade the regions that represent or correspond to those different inequality statements. So all values greater than 6 and all values less than 4. And we can represent that in interval notation in this case as negative infinity to 4 with a square bracket, union, square bracket, 6 to infinity, again indicating that the values of both 4 and 6 would make this original inequality statement true. In example 9, we have one extra step that's not a very complicated step. We begin with the absolute value of 5 minus 2x is greater than the absolute value of negative 1, but the absolute value of negative 1 is just 1. So what we would have is 5 minus 2x greater than 1, and 5 minus 2x less than negative 1. And then we could solve each of those inequality statements to get x is less than 2, and x is greater than 3. So look out, because as you solve those, you would end up either multiplying or dividing both sides by a negative, which would cause those inequality symbols to flip direction. And we would end up with an open circle at 3 and shading all regions to the right, and an open circle at 2 and shading all regions to the left. Translating that into interval notation would give us negative infinity to 2 with rounded parentheses, and then another rounded parenthesis at 3 to infinity. In example 10, we end up with an interesting case. We'll start off things the same way with 3x plus 5 greater than negative 4, and then 3x plus 5 less than positive 4. So again, we're flipping the direction of that inequality and using the opposite of that original value to set up this second inequality statement. In the first case, we would subtract 5 to the other side and then divide by 3 to get x is greater than negative 3. And then in the second case, we would use those same operations to obtain x is less than negative 1/3. So if we look at graphing both of these on a number line, we could start off with negative 3. We would have an open circle, and we'd be shading all values to the right. And then if we graph negative 1/3, which would be a little bit less than 0, we would have an open circle at negative 1/3, and we would be graphing all values to the left. So in this case, we don't end up with a disjoint solution. We end up with solutions pointing in opposite directions, but also overlapping with each other. Since all values are covered in that case, we would say, rather than this being a disjoint solution or having a bounded solution, that actually all values from negative infinity to infinity are solutions to this inequality statement. And again, we could get to this idea intuitively as well, because we know that the absolute value of x always has to be greater than or equal to 0. So if instead what we're doing is saying that our absolute value statement has to be greater than negative 4, that's always going to be true. Regardless of what value we plug in for x, we're always going to end up with something that's 0 or larger, meaning we're always going to definitely end up with something larger than -4.